S3 is for physics, input, process, and output devices. Within this section, we're looking at all three different types of devices, and there are elements of this section which are more National 4 and others which are more National 5. Throughout the show, I'll highlight which ones are which. Output devices. Electrical and electronic systems can be split into three parts, as we reminded before: input, process, and output. The input part detects or senses or takes in some type of energy. The process part processes electrical energy, and the output part gives out useful type of energy for whatever the purpose the circuit is designed to do. So LEDs, motors, loudspeakers, relays, and lamps are all examples of output devices. The output device converts electrical energy into another useful form of energy, and here are some examples. LED converts electrical energy into light. A motor converts electrical energy into kinetic energy. A loudspeaker connects electrical energy to sound. A relay takes electrical signal to close a switch. A lamp changes electrical energy to light energy. And a solenoid changes electrical energy to movement. From practical and/or research, you should be able to complete the following table. So let's have a look. LED. Sometimes you'll see this with a line drawn through. Light comes out, so we see here arrows coming out. The energy output is light, and possible uses, well, we use LEDs a lot for lots of things around the homes, but I'm going to say torch. Motor, circle of them. Energy output is kinetic. Possible use could be an electric car. Loudspeaker. Energy output is sound, and a possible use could be a speaker. Relay is a little bit more difficult to draw. We have a switch, then we've got a coil of wire here. Output is kinetic. And relays are often used in big switching circuits for large devices. So a large device could be something like a dishwasher, or potentially something with a very, very large motor. So think of a dryer. Lamp, probably the most well-known of circuit symbols. Energy output is light, and possible use is, well, lights in the house. Output devices. So output devices can also be classified as either digital or analog. A digital device basically switches directly from one value to another. It's on or off. An analog device can have a continuous range. So think of it like an LED. So an LED is on or off, but you can get dimmable lights where there's a range of brightness. So analog output has a continuous range, and that can change. So here's examples of digital and analog outputs. So digital, we can set our times, it's going to be 1 second at a time, whereas our thermometer is likely to go up or down. The clock is always digital. It switches directly from 10:33 to 10:34. The thermometer is analog because it has a continuous range. The mercury can stop anywhere on the scale, It could also stop in between numbers on the scale. There's no in between in digital. So have a look at the following devices. Can you classify them as being analog or digital? Well, LEDs are on or off, so they are digital. A lamp can change in brightness, so that is analog. Loudspeaker, well, it'd be very boring if we just had one tone, so that's going to be analog as well. A buzzer is either on or off, so that's digital. Motors can be fast or slow, so your motor is also going to be analog. But your relay is either on or off, so that's digital. LEDs. LEDs, light-emitting diodes, are low-voltage output devices which operate on small currents of around about 60 milliamperes. And normally they have an operating voltage of between 1 and 1.8 volts. An LED must be placed correctly in a circuit or it will not light up. It conducts in one direction only, and that's what makes it beautiful. When correctly positioned, the current in the circuit will flow into the tip of the triangle of the LED symbol. This is shown on the next slide. So here we have a circuit diagram where we're showing a battery connected to a switch, a resistor, and an LED. And we can see that the negative terminal of the battery, remember the short end is our negative terminal, is connected to the tip of the LED. So the LED is going to conduct. It should be noted that LEDs are most often connected with a resistor in a series, and the resistor in a series limits the current going to the LED, because if too much current flows to the LED, it will not work. We could also say the resistor is there to limit the potential or the voltage across the LED. So the resistor R protects the LED by limiting the current. It stops the LED from overheating. LEDs are often used as indicator lights. For example, the indicator on your remote control, you press a button, you know that it's sending a signal to the television. Example, in the following circuit, the LED is rated at 2 volts, 100 milliamperes. Notice milli, that's times 10 to the negative 3. Calculate the resistance of the resistor. So here's our circuit. As this is a series circuit, the current in the LED will be the same as the current in the resistor R. That is 100 milliamperes. Remember, milli or M means times 10 to the negative 3. There's 6 volts available from the supply. The LED only operates at 2. That means there's 4 volts left over for the resistor. We need to apply Ohm's law. So we have a supply voltage of 6 volts. We know that the LED is 2 volts. And we also then can work out that the voltage of the resistor is equal to 4 volts. Now, you working this out shows you understand the operation of an LED. So working out the voltage across the resistor actually gives you 1 mark. Unfortunately, if you don't work this out, then later on you're only going to receive 1 mark for the equation. So the equation V equals IR gives you 1 mark. At this point, we need to substitute in the correct values. We want to find the voltage across the resistor in order to find the resistance of the resistor. So we have to use 4 volts with the current, which is the same all the way across the resistance, which is 100 times 10 to the negative 3, in order to find the resistance of the resistor. 4 is equal to 100 times 10 to the negative 3 multiplied by resistance. Resistance equals 4 divided by 100 times 10 to the negative 3, or 0.1, which gives us 40 ohms. 1 mark for the equation, 1 mark for the substitution, 1 mark for the final answer. So this is an A-type question that's worth 4 marks. But if you don't do the first step, if you don't work out that 4 volts, then you'll only end up with 1 mark coming from using the equation.